This video will describe how to assemble and use Cremat's CR-150-R5 evaluation board. This board can be used to evaluate any of Cremat's charge-sensitive preamplifier modules. This board does not have to be used with any connectors installed. You can simply wire cables to these positions. Most users choose to install the supplied BNC connectors onto the board. If the detector bias is expected to exceed 500 volts, we recommend that SHV connectors be used at the bias in and input positions. To install the BNC connectors, carefully insert the leads from the connector into the two holes on the board. Do not apply force, the leads should easily enter the holes if properly aligned. Solder one of the leads to the board. Afterwards, gently push the BNC connector onto the board while heating the solder joint. This should seat the connector flat against the board. It is important that the connectors be flat against the board. Then solder the remaining lead. We recommend using a liberal amount of water-soluble flux when soldering. Solder the test input and output connectors into place. Solder the BNC connector mounting posts to the board. This soldering may require 2 soldering irons if your soldering iron is not sufficiently powerful. The first step is to deposit solder. Afterwards, use both irons together to heat the solder. Add 2-inch wires to the input and associated ground points. If you intend to use an SHV connector for the bias in, then add a 1-inch wire to this point. If you are not using SHV connectors, do not install this wire. If you are not using SHV connectors, remember to also install the remaining BNC connector onto the board in the bias in position. There are 2 unpopulated positions on the board labeled R1 and R2. These are available for the user to shunt the bias filter resistor and bias resistor respectively. This is the schematic diagram of the CR-150-R5. Here is a detailed view of one section. The detector current flows from the bias supply through the filter resistor R14 and the bias resistors R13 and R4. The bias voltage at the detector is the voltage at the bias supply minus the voltage drops across R14, R13, and R4. If the detector current becomes large, the voltage drops across these resistors can significantly subtract from the bias voltage across the detector. If these voltage drops become unacceptably large, the user can add shunt resistors to reduce the drops. These optional shunt resistors can be placed at these locations. Some approximate knowledge of the detector current is needed. You can choose appropriate shunt resistors using this table. It is not necessary to use any shunt resistors, but keep in mind that the bias across the detector may be significantly less than the applied bias. After adding any optional shunt resistors, we are ready to clean the board. Add some liquid soap and brush lightly. Then rinse the board under hot running water while brushing. Dry the board completely before continuing. We can now install the CR-150-R5 board into a housing. This example uses the CR-150 box R5 HV housing, which uses the high-voltage SHV connectors. Shielded housings are important to prevent ambient electromagnetic interference from being picked up by the charge-sensitive preamplifier. Secure the board in place within the housing by installing and tightening the supplied nut and washer hardware. Draw the wires tight to their respective destinations and trim their length. Solder the wires to the connectors. There are two different methods you can use to power the board. The first is to apply both plus and minus voltage to these points. The voltage must be in the range of plus and minus 8 volts to plus and minus 15 volts. The second method is to power the board using a wall-mounted power supply using this connector. The 24-volt wall-mounted power supply should be electrically floating with respect to the preamplifier. We recommend the CR-150-R5 for this. Install the charge-sensitive preamplifier module onto the socket in this direction. Without the metal cover, the preamplifier is highly susceptible to ambient electromagnetic interference. But with the cover in place, the ambient interference is effectively shielded.